Hello, Legacy Sabers, Marsh here. So today we're going to talk about graphing and writing ellipses that have been translated. Again, you're going to want to have your conics foldable, something to write with, and then maybe a couple of colors just to help with those vertex and those co-vertices. So last time we saw one another, we talked about an ellipse that was starting at 0, 0 for a center. Today, the point is we're going to be moving that center to HK. Just kind of like how that circle had that HK in its problem or in its equation, we're going to be moving ours as well in this ellipse. Now notice it is negative h in the formula and it's a positive h for our ordered pair. So this will be just like we're going to have to see the opposite of what is being shown. Let's jump in. Let's try the first problem. So I have x minus c quantity squared divided by 49 plus y minus 5 quantity squared divided by 4 is equal to 1. So first, I need to figure out what is my major axis. Remember, it depends on who has the bigger denominator. Since the x has the bigger denominator, this ellipse will be a horizontal major axis for it. And the center, not 0, 0 this time because the 3 is with the x and then we have a 5 with the y. So our center will be 3, 5. So let's go over here on our graph. 3, 1, 2, 3, 4, 5. I think that's 5. 1, 2, 3, 4. Yes. And I'm going to put a little c by that, so I mark that as the center. Now, let's find our a. Remember, a is the square root of the bigger denominator. So this a will be 7. My b is the other denominator square root. So I'll be a 2. And then c, remember we had that formula, a squared minus b squared equals c squared. So we're going to go 49 minus 4. That's going to give us 45, and that is c squared. So let's square root both sides. We're going to get 3 square root of 5 for our c value. Square root of 45 is very close to 49, so that would be 6.5 roughly, probably for a decimal. 6.4, something like that. Now, my vertices, I have to go horizontal, my a value. My a value is 7, so I'm going to go horizontally, so that means left and right, from my center, 7. So on my c here, I'm going to go 7 to the right. 1, 2, 3, 4, 5, 6, 7. Put a dot there, mark it as a vertice. Do the same thing backwards. 1, 2, 3, 4, 5, 6, 7. Put a vertice. Now, let's write those ordered pairs out. That seems to be 10, 5, that's the guy on the right, and negative 4, 5. Now, notice, all I did, if you wanted to find it without a graph, you could theoretically take your a value and add and subtract from the x value, that's 7. That would also work for this as well. Let's find those co-vertices. I'm going to change my color here. So co-vertices, we're going to go up and down my b value. So I'll be 2. So I'm going to go up 2, put a CV beside that, down 2, put a CV beside that. So my co-vertices ordered pairs are 3, 3, it looks like, and 3, 7. Again, notice we're basically taking that b value and adding it and subtracting it from that b value of those co-vertices. My foci, I'm going to change my color again. The foci, we're going to go 3 square roots of 5 from my center. Remember, it has to follow the major axis. So that means left and right, I'm going to be going 3 square roots of 5. So from my center, I'm going to go left and right, 3 square roots of 5. Basically 6.5. So I'm going to go 1, 2, 3, 4, 5, 6, and a little bit more. That is one of my foci. And then 1, 2, 3, 4, 5, 6, and a little bit more. That is another of my foci. I'm also going to connect my dots, so don't forget to do that. Ooh, jeepers, Marsh, connect the dots better. There we go. Now, my foci. This is a little weird to write them. Would you agree with me that the y value is definitely 5, right? This dot is definitely on 5. So I know it's going to be 5 at the end of my ordered pair. Now, the other thing I need to think about, notice we said we went to the right 6.5. So I added 6.5 from 3. So I went 3 and 6.5 more. So I'm going to write that I started at 3, because that's where I started, and then I added 6.5, which is the same as 3 square root of 5. So I started at 3, I added 3 square roots of 5, comma 5. That's this ordered pair right here. But I also went to the left 3 square roots of 5. So I'm going to say I started at 3 and I subtracted 3 square roots of 5. That is the left side's ordered pair. Now notice I could write these together. I could say 3 plus or minus 3 square roots of 5, comma 5. However, if it works best for you to write it in 2 separate pieces, that works too. Let's try another one. This one's not equal to 1, so let's take care of that. I'm going to divide everything by 64. So we have x plus 1 squared over 8 plus y minus 1 squared over 64 equals 1. Now, it has a bigger denominator under the y, so that must mean we are vertical. My center is negative 1, 1. That is because the positive 1 inside the x, so we have to think opposite, and then opposite on this y as well. So let's graph that dot here. Let's put a C on that so I know it's my center. Let's find our A. So our A is the square root of the bigger one, so that'll be an 8. My B will be the square root of 8, so that'll be 2 square roots of 2. And then my C, I need to do 64 minus 8, which would be 56. Square root of that. Does 56 have a perfect square in it? Ooh, I think it does. I think there's a 4. Let me check on my calculator. Oh, yes. So I know 56 is 2 square roots of 14. Simplified. As a decimal equivalent, 56 is between 49 and 64. So I'm going to guess 56 is probably close to 7.5 for a decimal equivalent. Pretty close to that. So my vertices, remember that is my A value and I have to follow my directions. I said go vertical 8. So we're going to go vertical 8 from our center. Put that's a vertex. I'm going to go down 8. So that'll be 1, 2, 3, 4, 5, 6, 7, 8. And put that as a vertex. So I have ordered pairs of -1, comma 9 and -1, comma -7 for one of those ordered pairs there. Let's find the co-vertices. Change my color. Co-vertices, I'm going to go 2 square roots of 2 left and right from the center. So I'm going to go, 2 square roots of 2. I don't even get a decimal equivalent. Well, square root of 8, 2.8 roughly, 2.9, something like that. So I'm going to go 1, 2, and a little bit more. 1, 2, and a little bit more. Those will be my co-vertices there. Again, I have to write these kind of a little funky. We do know that the y value is 1, right? Because it's sitting on the 1. So I started at -1 and I added 2.8 and I subtracted 2.8. So I'm going to say I started at -1, I added and subtracted, but I'm not going to put 2.8. I'm going to put the exact form, 2 square roots of 2. Now, last color change here. Let's find ourselves some foci. So I have to go from my center vertically 7.5. So right here is one of my foci. The other foci is right here. And then I'm going to connect my dots, my vertices and my co-vertices. Did better that time than last time. Now, my foci. I know that the x value stayed -1 because I didn't move off of -1, but I started at +1, added 7.5, and I subtracted 7.5. So I'm going to say I started at 1, I added and subtracted, aka went up and down, 7.5. But again, I'm going to write the exact value, 2 square roots of 14. Now, let's work backwards. Let's try writing. Now, they gave me a graph. I need to figure out the center. I need to figure out my A value, and I need to figure out my B value. Those are the 3 things to make an ellipse. So first, center. It looks like the center is right here, I think, because it's definitely in the middle, left and right, but up and down, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yes, it looks like that is the center. That ordered pair seems to be 1, 2, 3, 4, comma 2. I think that's that number right there. 1, 2, 3, 4. Yes. So 4, 2. I'm going to start writing out my ellipse equation. I know that it is always something that looks like that. And I know it's going to be x minus 4, y minus 2 on that information. Now, I need to find the A and the B. Now, let's remember, A value is how far your center is to a vertex, and B is how far your center is to a covertex. And since the major axis is vertical, aka this is an up and down ellipse, right? It's taller than it is wide. So that means my A value has to go under the Y. So I need to find out how far is this value right here. 1, 2, 3, 4, 5, 6, 7 value there. So A is 7. My B value, aka how far is it to a covertex, is 2. So my A value squared has to go under the Y, and my B value squared has to go under the X. And that is because it is a vertical ellipse. Now, I'm going to be super mean now. I'm going to take away your graph. But we can graph it, right? Let's do a quick little sketch. So 2, 13, 2 13s all the way up here. 2, -1 all the way down there. And those are vertices. And then my co-vertices are 5, 6, and -1, 6. So let's connect the dots. Notice, it is definitely a vertical ellipse, right? It's wider than it is fat. Taller than it is wide. So that means I know that this is a vertical ellipse. And again, I need to find the center. I need to find my A value, and I need to find my B value. My center, we're going to need that midpoint formula again because it's in the middle of the 2 vertices. So 2 plus 2 divided by 2, 13 plus a -1 divided by 2. So I'm going to get 4 divided by 2, 2. 13 minus 1, 12 divided by 2, 6. So my center, aka middle of those 2 vertices, is 2, 6. And now my A value. I need to find how far my center is to a vertex. So 2, 6 to 2, 13. How far is that value? 7, right? That is 7, distance of 7 from one another. I now need to find the center to a covertex to find my B. So 2, 6 to 5, 6 is a distance of 3, right? Because 5 and 2, they're 3 away from one another. I now have all the pieces to make my equation. Let's write out our template. So I know it's x squared divided by something plus y squared divided by something equals 1. That's a constant. That's never going to change for us. I know my center, x minus 2, y minus 6. And since this is a vertical ellipse, I know that the a value squared has to be in the denominator of the y. So this will be a 49 there. And then the b, we're going to square that. We're going to get a 9 there. And there is my equation. Ooh, cut through that one. Bad box job. Let's try number 7. So they're giving me vertices of 4, 13 and 4, 3, and then foci at 4, 11 and 4, 5. So let's do a quick little sketch here. So 4, 13's all the way up here. 4, 3 would be like right there. 4, 11 and 4, 5. So notice they didn't give me co-vertices. They are somewhere over here. So I know since these are vertices, I know that again, this is a vertical ellipse. That's the only reason I know though. That because they gave me vertices and foci and those are going up and down. Another way to know it's vertical without the sketch, notice that your vertices are changing in the y value. That would be another way to notice that it is a vertical ellipse. So again, we need center, a value, and the b value. My center, let's find it again. It is the midpoint formula again. 4 plus 4 divided by 2, 13 plus 3 divided by 2. That looks to be 4 comma 8 is what I'm seeing there, because 13 plus 3 is 16 divided by 2 is 8. Now, my a value is my vertices to the center. So 4, 8 to 4, 13, or 4, 8 to 4, 3. I'm going to do to 4, 3. Same value though. I get a distance of 5. So my a value is 5, because that is vertex to center. And my co-vertex to my center. I don't have that b value. I can't find it. They didn't give me anything about co-vertices. But I did get something about my foci, and I know my center to my focus, or to a focus, is my c value, right? So I do know that my c value is 3, because 4, 5 to 4, 8 is a distance of 3. That doesn't help me though. C is not in our problem. It's not in the equation. So I need to find the b value. Well, isn't there that formula? Don't we have that a squared minus b squared equals c squared? And in the graphing, we always use that to find c, but can't it work backwards to find our b? Let's plug in what we know. We know that a squared is 25. Don't know b squared. That's what we want. And I know my c squared is 9. Let's solve. So I'm going to subtract 25. You're going to get negative 16. I know b squared is 4, or b. Oh, hold up. B squared is 16. Sorry, guys, jumped the gun. B is 4. There we go. Now, I have all the pieces. Let's write out our template. We know it is x something squared over something plus y something squared over something equals 1. My center is 4, 8, so I'm going to write those in the parentheses. We said this is a vertical ellipse, so the a value squared has to go under the y, so that's going to be 25. My b squared is going to go under the x. Notice, c is not being used. The only reason c was created and used is because we needed it to unlock the b value for us. And the last one of the video. I know, taking a while. Let's do a little sketch. I was given co-vertices and foci. So negative 10, comma 8. Ooh, that's a dot right about there. Negative 10, comma 16. That's all the way down there. Foci of negative 5, negative 4, and negative 15, negative 4. Ooh, Marsh kind of drew these kind of weird. Well, those are foci, right? So that must mean that I have vertices that are further out. So I know my graph looks something like this. Kind of weird. It definitely is a horizontal ellipse, though. The other way I can tell it's a horizontal ellipse is the foci are changing via the x. Can't look at the co-vertices, though, because the co-vertices are not along your major axis. And that's what we're trying to find, is the major axis value. So I, again, need the three things. I need a center, I need to find A, and I need to find B. My center is in the middle of my co-vertices. It looks like to be -10, comma, 8 minus 16 is -8, divided by 2 is -4 for my center. My A value, I don't know my A value, because I don't have center to vertex, right? We didn't get any vertices. They didn't give us that. So I don't know A. But I can find B. Center to a co-vertex seems to be a distance of 12. And I did get C. Center to a focus looks to be 5, distance of 5. Let's plug into our cute little formula. So A squared we don't know. We do know B, and we do know C. So A squared minus 144 equals 25. A squared is 169. So if I square root, I will get A is 13. Ooh, Marsha's running out of room. I'm going to do some erasing. Meep, 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 meep. Okay, there we go. So I have some room. My template, write that out. Oh, we're running out of room. Marsh. There we go. Now, it is horizontal. So that means my A value has to be under the X. The bigger denominator has to be under the X because it's horizontal. So that means this will be 169 underneath the X, and it'll be X plus 10. Almost forgot that. And then Y plus 4. And then this denominator will be, in fact, 144. I know that these ellipses are quite difficult. They are a lot of information. You are definitely having to pay attention to everything you have and everything you need. We're going to do quite a few examples in class when you get back to me. Until then, though, I will see you later, Sabers.